Hi everyone. Today we are going to be continuing our work with multiple representations of functions. So in the last section, you were still given the rule to be able to create the table and the graph, or you were given the information on the graph to create the table and then the rule. Today, you're just going to be given some information. You're going to be given that verbal expression, and then you're going to be able to create the rule, create the table, create the graph. So now we're working strictly from those word problems. How do we create the rule? How do we know what gets multiplied? How do we know what gets added? And then can we use that information to do independent, dependent variable, create the table, and then create the graph? So problem number 1 says student council is holding a bake sale. They are charging $5 for each brownie. So there's my information for my rule. Write an equation to find the total amount of money earned T for selling B brownies. So when I write my rule in this situation, I am going to use T and B because they specifically defined those variables for this situation. And these variables are not correct, so we're going to fix those really quick. In this situation, when I want to find the total amount of money earned, that means that my equation is going to be T equals, because T is going to be the dependent variable, so money earned is going to be dependent. Because I have to do something in order to earn that money. So the money is the output in this situation, and then the input is going to be the number of brownies. And they are charging $5 for each brownie, which means $5 times the number of brownies. So if I buy no brownies, if I buy 1 brownie, if I buy 2 brownies, if I buy 3 brownies, how much money am I going to earn? Well, if I don't sell any brownies, I'm not going to earn any money. If I sell 1 brownie, I'm going to earn $5. If I sell 2, I'm going to earn $10. And if I sell 3, I'm going to earn $15. I changed the axes on my graph because they were not appropriate for the situation. So I changed it to money earned along the y-axis because that is my output. Remember, this is still the x-axis. This is still the y-axis, even though we're using T and B to represent our variables. So 0, 0, 1, 5, 2, 10, and then 3, 15. And I can connect my dots. So again, starting with a verbal expression to be able to write an equation to create the table and then the graph. So now we should be able to start you in any one of these representations, and you should be able to get the other ones. For example, we did where I gave you a graph and you were able to create the table and then an equation. If I give you a table, you should be able to create an equation and then a graph. And then we should also be able to write some kind of or understand what verbal expression they give us to represent the situation. Problem number 2 says, at the beginning of the season, T.Y. pays Tom Brady, because he's the best, not really, $5 just for being awesome. Additionally, he pays him $2 for every complete pass he makes. Write an equation to find the amount of money T.Y. will pay Tom after completing n passes. Also create a function table and graph to represent the situation. So first I'm going to identify independent and dependent variables. So to find the amount of money, he will pay Tom after completing n passes. So we have to complete a number of passes before we earn money. So money paid. So down here I've got number of passes. And then up on the side I'm going to have money paid. Okay, remember that typically money is your output because the money is a result of something happening in your rule. This problem says that TY is paying Tom Brady $5 just for being awesome. So I'm going to say T equals $5, and he's just getting that $5. It's not happening every single time. He's just getting $5. Additionally, so I'm going to do plus, he pays him $2 for every complete pass that he makes. So 2N. Because that's the thing that he's doing over and over and over again. So I'm going to create my table using this rule. If Tom Brady completes no passes, 1 pass, 2 pass, or 3 passes. If Tom Brady completes no passes, he's still going to get $5 for being awesome. If Tom Brady completes 1 pass, he's going to make $5 for being awesome, plus $2 for completing the pass, so he's going to make $7. If he completes 2 passes, he's going to make $5 plus $4 for his complete passes. And then for 3 passes, he's going to make $5 plus $6 for those completed passes. So we should have 5, 7, 9, 11 for our output values or our Y values. Remember, this is the X axis. This is the Y axis for my table. So when I'm plotting points, even though it says N and T, I'm still doing X first and then Y. So left and right first, then up and down. So 0, 5, and this one is not marked perfectly, so I'm going to have to kind of estimate a little bit. 1, 7, 2, 9, and then 3, 11. So it should look like a pretty straight line. I think I look pretty good here. And I'm going to connect those dots. We did talk about how, for the most part, we're going to be working in quadrant 1. So everything pretty much, for the most part, in this type of scenario is going to be positive, positive. So everything should be in quadrant 1. And again, you should be able to now work with all 4 ways that we represent a function. You should be able to interpret a verbal expression to write an equation to then create a table and then a graph. You should be able to use the table to create an equation and a graph. And you should be able to use the graph to create the equation and the table. So now that we've kind of worked through all of these representations, you're going to be asked to work with them fluidly with each other.